Hello students, today we're going to kind of wrap up this whole linear equations thing and we're going to look at the last form that you're going to be learning this year. Hopefully by now you've mastered slope-intercept form, which is y equals mx plus b, and you've mastered point-slope form, which is y minus y1 equals m times the quantity of x minus x1. Well, today we're going to kind of take both of those equations and move them into what we call standard form. So 5.4 is write linear equations in standard form. And you're wondering, well, what is standard form? The thing that you need to know about standard form is that x and y are always on the same side of the equation in standard form. So standard form is capital AX plus capital BY equals capital C. Now, this is the first time we've introduced that A, B, and C to you. Those are just variables, and you don't really need to worry about it. Don't be freaked out about it. This is a capital B, which is not the same as the y-intercept lowercase b. Those are two different things, and this is probably the last time that we'll look at that A, B, and C until next semester. Just know that A, B, and C are all whole numbers. When we write in standard form, we have whole numbers or integers. Typically, there are no fractions, okay? So let's say, for instance, I give you an equation in standard form, 2x plus 4y equals 6. Notice that x and y are on the same side of the equation, and so that's what makes it in standard form. Well, let's say I need another equation that is exactly the same as this line in standard form. Well, I have two options. I could multiply everything in that equation by the same number, or I could divide everything in that equation by the same number, still making sure that I have integers, no fractions. So let's say I'm going to multiply everything by 3. 3 times 2x would be 6x, plus 3 times 4 would be 12y equals 18. So I just took that entire equation, multiplied everything by 3, and got another equation that is exactly the same line. Well, let's say I want another one, but this time I'm going to take this original equation, 2x plus 4y equals 6, and divide it by 2. And when I divide by 2, I'm still going to get integers. I won't have any fractions. So 2x divided by 2 would be just x, and 4y divided by 2 would be 2y equals 3. So all three of those equations give me exactly the same line. They're just all equations in standard form with different numbers, but they're all the same line. The next thing we want to look at is writing an equation in standard form for a line with the following characteristics. So sometimes it's just going to tell you a few things about the line, and you've got to come up with an equation in standard form. Here is where we're probably going to have to start with a line in slope-intercept form or an equation in point-slope form, and then put it into standard form. So for example, let's say that I have a line that passes through -3, 2 and has a slope that equals 1. So I know a point and I know a slope, so probably I want to start with point-slope form of the equation. So I can put this in point-slope of the equation, manipulate a few things, and then put it in standard form. So I would do y minus 2 equals m, which is 1, times the quantity of x plus 3, because remember it's minus -3 and that's plus 3. So now I'm going to get x and y on the same side of the equation. So y minus 2 equals x plus 3. And I really like my x being positive, so I'm really going to leave that there. So I'm going to move the y over to the other side, and I'm going to move the 3 to this side. So that's going to be x minus y equals -5, or x minus y equals -5. Notice that the coefficients of x and y are integers, and I have no fractions, and x and y are on the same side. So that is the equation of the line that passes through -3, 2 with a slope of 1. And it's in standard form. Well, let's say that I'm given 2 points that lie on that line. So I have 2 points, 0, 1, and -6, -9. Well, I don't have a slope, so the first thing I've got to do is find my slope. So let's do that. So we're going to do y2 minus y1 over x2 minus x1. So I'm going to do -9 minus 1 over -6 minus 0. That equals, I forgot my m, Negative 9 minus 1 is negative 10. And negative 6 minus 0 is negative 6. And I simplify that to positive 5 over 3. Since it's negative and negative, it becomes positive. Divide both of those by 2, and I get 5/3. I'm going to leave it at 5/3 because my slope needs to be a rise over run. 5/3. Now, I'm going to take those 5/3 and I think, do I know my y-intercept from either of these points? Well, actually, I do. When x is 0, y is 1, so my y-intercept must be 1. Now, that's not always going to be the case. Sometimes you're not going to know, and you're going to have to plug this into y equals mx plus b to figure out what the y-intercept is. But this time, I know the y-intercept is 1, so now I'm going to write my equation in slope-intercept form and then change that to standard form. So in slope-intercept form, my equation is going to be y equals 5/3 x plus 1. Y-intercept is 1, slope is 5/3. Now, in order to be standard form, I have to get x and y on the same side. So I'm going to leave x there because x is positive. I want x to be positive, that's just the way I like to be. So 5/3 x is going to stay there, and I'm going to move the y into 1. So we have 5/3 x minus y equals negative 1. But you'll notice now that I have a fraction, and I don't want fractions. And so I'm going to draw squiggly so I can separate. I don't want fractions, so I need to multiply that entire equation by some number so that no fractions are left. And that number would be 3, because that's what my denominator is. So I'm going to multiply this entire equation by 3 and get an equation in standard form. So 3 times negative 1 is negative 3, and 5/3 times 3 is just 5x, and then negative y times 3 is negative 3y. So my equation in standard form would be 5x minus 3y equals negative 3. The last part of this whole standard form situation has me writing horizontal lines and equations for vertical lines that pass through any point. So write the equation of the horizontal and vertical lines that pass through the given point negative 1, comma 4. So I'm looking for a horizontal line that passes through that point and a vertical line that passes through that point. Well, let's just draw a little tiny graph. And let's go to negative 1, comma 4, which would be about there. So what I'm looking for is the equation of this line, which is the vertical line, and the equation of this line, which is the horizontal line that passed through that point. I hope that's not too hard to see. So I'm going to start with the vertical line. You'll remember with a vertical line that always starts with x equals something. Well, what does x equal in this equation? Negative 1. So the vertical line is x equals negative 1. That's the equation of this vertical line. And the horizontal line, if you remember, is the y. The y stays the same. So the equation for the horizontal line is y equals 4. That's it. You just have to remember which one's vertical, which one's horizontal. You want to know the way I remember it? If you see vertical, if you look at the top of your x, you see a V. That's how I remember that's vertical. With horizontal, most of the time when we write a y, it's like this. If you flip that y upside down, doesn't it look like an H? So the way I remember it is horizontal, rotate the H, I've got a y. So horizontal always y equals, vertical is always x equals. Maybe that'll help you too. Here's your practice problem for tonight. What I would like for you to do is to take these 2 points and write the equation of a line that passes through those 2 points in standard form. Just a hint, the first thing you need to do is find the slope. Then you're going to have to use that slope in one of these points to figure out what the y-intercept b is. Then you can plug that into an equation and then move x and y to the same side. If you have any questions, email me or Edmodo post me, but turn your work in after you take a picture of it, submit it through the turn in button on Edmodo. If you can, please turn it in with the submit button. That helps me instead of you just sending it to me as a direct post.